Here, the problems on sedimentation tank. The question number one. The problem is like that. The maximum daily demand at a water purification plant has been estimated as 12 million liters per day. Design the sedimentation of a suitable sedimentation tank. I already told, fitted with mechanical sludge removal for raw supplies. Assume the detention period of 6 hours and the velocity of flow of 20 centimeter per minute. Here, the maximum daily demand of water, the amount of water is required for this community area is 12 million liters per day. We need to design the size of what is length, breadth and depth of the sedimentation tank. He already told that no manual cleaning will be there, mechanical cleaning will be there. Suppose he has not given the detention period like this, you can assume the detention period as 6 and velocity of flow is 20 centimeter per minute. Let us solve it. So first thing is solution part. So this is the requirement of water for the community area. We need to calculate how much amount of waters to be treated for 24 hours. Let us quantity of water to be treated in 24 hours. Quantity of water is treated for 24 hours. It is the water requires 12 million means 10 power 6 we get in liters. So he has given detention period as 6 hours. Detention period is nothing but the suspended solid. If the waters come from this place, it's get allowed to the sedimentation tank. The time required for settling of the sediments or waste is called as detention time. So quantity of water is we need to pump for 24 hours is 12 into 10 power 6 liters. Then quantity of water treated during the detention period of 6 hours. So for that 12 into 10 power 6 divided by for 24 hours into 6. 6 is nothing but all the units are 20 centimeter per minute we have here. For that 12 into 10 power 6, the 6 hours is converted into minute. We need to divide it by 24. It converts liters. So 3 into 10 power 6 liters. So we can also write it as 3 into 10 power 3 meter cube or 3000 cumax cubic meter. So next thing, he has given velocity of flow is 20 centimeter per minute. So we have the very important formula here. Length of tank L is equal to velocity of flow into detention period. Velocity is converted into meter per minute is it will be meter means 10 power minus 2 0.2 meter per minute. So 0.2 into detention period is 60, that is in hour. 60 converted into meter, so 72 meters. Okay, here 1 minute is there, here minute is there, minute get cancelled, and the unit is in meter. So next thing, cross sectional area. Cross sectional area, for that we have formula capacity of tank divided by length of tank. So capacity we have 3000 divided by 72. So this is in meter, this is in meter cube. So we have this is in meter, this is in meter cube. So 1 meter, so meter square. What is the value? 41.67. 41.67 meter square. So here one thing is there, we are assuming here, so a tank means something length, breadth and depth will be there. So LBD should be there. We have L, we didn't get the breadth, we need to find the depth. We are assuming depth as 4 meter, therefore width of tank is equal to this area, what we got, 41.67 divided by depth of much 4, we get breadth of 10.42, say it as 10.5 meter, and that's using the freeboard. Freeboard is nothing but, suppose freeboard is nothing but, this is the horizontal tank. If the water get filtered, if it not passing due to some reason, it is overflow. If it's overflow, its water is falling to the back same side, so it again becomes contaminated. For that we have extra wall for protecting of this overflow is known as freeboard. So assuming freeboard of 0.5 meter, so freeboard 0.5 meter, so then overall depth is equal to freeboard plus depth and we have assumed as 4, so it become 4.5 meter. Finally you have to write what is the dimension of that. So dimension is equal to, what's the length we get, length of tank will be 72. Length, what is the breadth will be 10.5, and what is the depth will be 4.5, and make a box 2. This is the final answer.